Okay, we've got a sequence, 2n over 3n plus 1. And we have to find out if this converges or diverges. The way we find that is by taking the limit as n approaches infinity. So the limit as n approaches infinity is going to tell us if this converges or diverges. Because we're plugging in infinity, so we're going all the way to the end and seeing what does happen. What is its behavior at the end? If it reaches a constant value, that's going to converge. If it doesn't, it's going to diverge. So when we have n here in the denominator and n in the numerator, or if we had n squared here and n squared here, we just divide by that. We divide by whatever we have here, which is the largest. And in this case, not only is it the largest, but it's in common. We have it in the numerator and in the denominator. That's really good news for us. So limit as n approaches infinity, we divide by n. And here we also divide by n. And we divide this by n. Everything has to be divided. Limit as n approaches infinity. And so we have 2 over 3 plus 1. We plug in infinity into that n that's left there. And so this thing goes to 0. We're left with 2/3. We're left with limit as n approaches infinity is 2/3, which is just 2/3. So this converges. This converges. And this actually tells us something about the series. That would mean that the series of this, as it goes to infinity, the infinite series of that, would not converge. It would diverge, because it needs the sequence, the infinite sequence, to be 0. If the infinite sequence is not 0, that means that the series will diverge, as it does in this case, because this converges to 2/3.